Hello, gentlemen. Just welcome back. Got a couple more videos that we need to cover for Chapter 3, and then we need to do a little bit in Chapter 4. We're going to start today by solving exponential and logarithmic equations. All right, and then the last video we'll look at some different models that we have. But let's look at solving. We're going to do a couple examples of solving exponential equations. Okay, and this one's a pretty straightforward one, but I want to go through a process that I want you guys to get in the habit of doing that will serve you well when you start taking calculus. When I have obviously here I could use the one-to-one property because I have just e on both sides. But in general, one of the things I want to do is to take the ln of both sides. Remember, ln and e are inverses of each other. So if I take the ln of both sides, I get ln of e to the negative x squared equals ln of e to the x squared minus 2x. Now what I'm able to do is I can use the power rule that we have, okay, which is going to bring that negative x squared term out to the front and the x squared minus 2x out to the front, like that. Okay. The next thing that I should note is that the ln of e is simply equal to 1. Okay, so that means that I get negative x squared equals x squared minus 2x. Now I just have a simple equation that I need to solve. Get everything on one side, bring this over to the other side here. I get 2x squared minus 2x, and I can factor out a 2x. And so now I have a situation where I have a product, and the product is going to be equal to 0. So then obviously either this term is equal to 0 or that term is equal to 0. And you guys should see that the solutions there are either going to be 0 or 1. Okay, that's a pretty straightforward one. Let's do one a little bit more challenging here. 6 to the 3x plus 10 is equal to 47. All right, first step that you want to do is you want to isolate that 6 to the 3x. Okay, so I'm going to bring the 10 to the other side, subtract 10 from both sides. So I get 6 to the 3x is equal to 37. Now this is where I want to teach you guys to be consistent with the way that you solve these equations. Okay, I still want you to take the ln, even though this is base 6 here, because again, a couple different reasons. One is we want to get in the habit of using ln's. That's what we're going to use in calculus most often. It's simple. It's one process. Okay. The other thing is no log base 6 button on my calculator. Okay. So I want to make sure that I'm going to be able to get a solution. Then if I use log base 6, then I'm going to have to use change of base later on. I'll get the same answer, but it's let's just be consistent and take ln of both sides. Okay. If I do that, I have the ln of 6 to the 3x equals the ln of 37. Now again, I can use my power rule. I can bring that 3x to the front. Again, I'm solving for x, so I'm going to divide by ln of 6. I should actually divide by 3 ln of 6, but I'll do that in a second. So I have the ln of 37 over the ln of 6, and that's going to equal 3x, so I'm going to divide both sides by 3, and I get 0.672. Okay? Do another one here. A little more in depth on this one here. Again, we want to isolate this term right there. Okay. Let's bring the 10 over. Let's add 10 to both sides. The next step I would do would be to divide by 8, and I get 3 to the 6 minus 2x is equal to 6. Again, I want to follow the same exact process. Let's take the ln of both sides. If I do that, I get ln of 3 to the 6 minus 2x equals the ln of 6. At this point, I can again use the power rule, and that's going to bring that exponent down. 6 minus 2x times the ln of 3 equals the ln of 6. And I get to that point right there. Be careful here. You have to evaluate these separately. You can't combine the ln's in the top and the bottom. Make sure you type in ln of 6 divided by the ln of 3. Okay. Here on this side, I need to isolate the x term. Okay. To do that, let's switch the signs here. I can think about taking, if I have 6 minus 2x equals ln of 6. I skipped a step here for you. Let's rewrite this. Multiply everything by -1. We'll go negative 6 plus 2x equals negative ln of 6 over the ln of 3. and then from there I'm just going to bring this sixth term over, and that's where I got this particular equation. I did this value out. I get about 4.369. Last step that I would need to do here is divide by 2. Okay? Let's do a logarithmic equation here. Ln of the square root of 8 minus 5. Let's rewrite that with an exponent. I can bring that exponent down to the front, and then I want to isolate the ln, so I'm going to multiply both sides by 2. So I get ln of x minus 8 is equal to 10. Now, at this point, I want to do, the inverse of taking the ln is exponential. So I'm going to raise both sides to the e power. So I get e to the ln of x minus 8 is equal to e to the 10. Now remember, these two are inverses of each other. Okay? So all I'm left with on the left-hand side is x minus 8. So I have x minus 8 is equal to e to the 10th power. I can bring that over and I get e to the 10th plus 8. It's a big number. Okay? Let's do another one here. A little bit different here. I got a bunch of things going on. But again, we want to isolate this term right here, and then we're going to get rid of this log base 3. Okay, so let's look at ways of doing that. Let's bring that 2 over. That's first. So I'm going to subtract 2 from both sides. Okay. Then we got to divide by -4, and I get -2 on this side. So now what do we do to handle this? Well, I need to look at what is the inverse of taking the log base 3 of a number. And the inverse of taking the log base 3 is raising 3 to each side. Okay, in other words, I'm going to raise both sides to 3. So I'm going to go 3 to the log base 3 of x minus 1 is equal to 3 to the -2 power, -2nd power. Okay, these are inverses of each other. This exponential with base 3 and this log of base 3 are inverses. All I'm left with on this side is x minus 1. Okay, now I've got to solve. I've got to add 1 to both sides, and I'm going to get 10 over 9. Okay, let's do one more. I think I have one more here. ln of x plus 1 minus ln x minus 2 equals ln of x. In this situation, let's rewrite. Let's bring all the ln's to one side. Now I can use my condensing formulas to combine all 3 of those terms. And if I do that, you should see that I get this, because I have quotient rule and quotient rule again. Okay. Now again, how do I get rid of the ln? I get rid of ln by raising both sides, e to the both sides power here. Okay. These two are inverses. Okay. Those two are inverses, so all I'm left with is what's right in here. I know what e to the 0 is. E to the 0 is simply 1. So now I've got to solve this rational equation right here. I'll bring the denominator over like that. Let's expand out and combine terms. So this side would have been x squared minus 2x. And I brought the terms onto this side. So I got x squared, so I really got 0 equals x squared minus 3x minus 1. I just rewrote that. Quadratic formula there. I can use my quadratic formula to solve quadratic equations. I use my quadratic formula. This was not factorable. Here are my solutions. Now I got to be careful because I only want the positive value here. And we have to go back and we have to check. And why am I only interested in the positive value? Well, if you think about the ln function, the domain of ln up here, domain was 0 to infinity. If I plugged in negative 3.303 into this one, or this one, I'm going to be undefined. Okay? And so I need to make sure that I'm in the domain, that my solution is in the domain. For this particular problem, the domain of this is 0 to infinity. This part right there is going to give me a shift to the right 2. So the domain of this one is actually 2 to infinity. And the domain of this term, this is a horizontal shift to the left one. This one's -1 to infinity. Okay? And -3.303 is not in any of these domains. All right? Here's some practice, fellas. Here's some of these. There's a few good examples of 3 each. 3 on exponential equations, 3 on logarithmic equations that you're solving. Make sure you get some good practice at this. I gave you a lot of problems to practice, but you know, it's going to take a little bit of practice once you're doing these. Just a couple things. You know, whenever I have some value, say, you know, 6 to the x equals 37, whatever I have here, whatever base, it doesn't matter. I want to get in the habit of taking ln of both sides. So I want to go ln 6 to the x is equal to ln of 37, and then bring that x down. Okay? And then I can solve. Remember, ln 37, ln 6, they're just numbers. Okay? When I'm dealing with logarithmic equations, you know, if I have log base a of, you know, whatever I have, x minus 1 equals 6, I want to isolate this log term. I want to get everything else on the other side. Isolate a log term. Now, when I get to this point, to get rid of it, I got to write log the inverse here equals a to the 6. Okay, and then these two terms right here, because they're inverses, that's going to be equal to x minus 1. So I would get x minus 1 is equal to a to the 6. Whoops. Okay, and then I can bring the 1 over. So again, understand the technique that when I'm using, if I'm solving an exponential equation, isolate the term that has the variable in it, and then we're going to take the ln of both sides. And when we're doing a logarithmic equation, isolate the logarithmic term with the variable, and then we're going to raise both sides to that power. Okay, and so there's a little different approach, but practice and make sure that if you have any questions, that you're emailing me, and we get those taken care of. Okay, one more video on this section, and then we'll move on to chapter 4.